So welcome everyone to the Uplink this week. My name is Mark Phillips. For people who haven't had the chance to meet me or chatted with me, I'm Vice President of Business Development at Helium. And today we're chatting with two teams, two ecosystem partners on the Helium Network, both building super interesting pieces of technology. The team at KST, which is based in, I think, Colorado Springs, and then the Losant team, which is out of, I'm going to make this up, but I used to know. Is it Indianapolis, Heath? Is that where you guys are at?
Oh, you're close. We're in Cincinnati, Ohio.
Oh, Cincinnati. I apologize for confusing those two. So, general agenda for today. I'm going to do a brief Helium overview. Most people on the uplink here are relatively familiar with Helium, and if not, there's going to be plenty of time at the end to ask questions. I will also take questions sort of in flow. So, if people want to take questions and pop them in chat here, I see people saying hello from Slovakia, Canada, Netherlands, the full global community showing up, which is super cool. Feel free to pop them in the chat and we'll take them as we can. We're going to spend most of the time talking about what KST and Losant are building on top of the Helium platform. So Bob from KST and Devin are going to walk you through what KST has built in terms of a sensor and a sensing platform. And then Heath is going to talk about what Losant is doing to ingest data and really make it easy to sort of use this IoT data in a way that makes it possible to build a full application. So we'll run about 30 minutes. We'll do questions, like I said, in between and sort of at the end. And thanks for everyone for joining. So let's see. So briefly covered the agenda already, but let's sort of roll through it. And I'm going to have everybody introduce themselves after I get to the Helium component of this presentation, so we can flow right into the Losant and KST piece. So we'll talk about Helium. We'll talk about LoRa and Helium and how it fits with the general RF ecosystem. And then we're going to sort of move into a use case, right? How do you take a packet and move it from sensor to cloud? How does that data from sensor to cloud end up in the dashboard? And then ultimately, what is the use case for this? I think people are going to end this uplink with a ton of information about how one very specific sensor can be used to build a whole slew of very interesting use cases. So about Helium. So we were founded in 2013 with a mission to make it easier to build decentralized wireless networks. And so just over the last 2 years, we've really nailed the model, which a lot of people on this uplink are very sort of committed to, which is building this decentralized people-backed network. We actually call it the People's Network. And at this point, it is the largest LoRaWAN network in the world, which is pretty staggering, considering that we've only been at this for about 18 months. And so when we think about why someone is using Helium, so why, for example, KST is recommending to their customers that they use the Helium network to deploy these sensing solutions, it's for a handful of reasons. So as I said, we are the largest public IoT network in the United States and in the world. At this point. So there's about 25,000 and growing hotspots. This is our LoRaWAN gateway. So 25,000 hotspots on the network across about 3,600 cities and 66 countries, which is pretty staggering. And the backlog for coverage creation is massive, right? There's about 150,000 plus hotspots from the major manufacturers in the ecosystem in the backlog about to be deployed across existing countries and then many, many new countries. So for example, we just started shipping to China, or one of our partners just started shipping to China, and there's already hundreds of hotspots online in China, and that's growing extremely fast. I left out some copy here. It's supposed to say diverse ecosystem with some supporting data. So we have a massive ecosystem of partners like KST and Losant growing to build solutions and applications on top of the platform. In addition to that, nearly every major manufacturer in the LoRaWAN ecosystem, whether it's a sensor, but more importantly, the gateway piece, are sort of coming to the Helium ecosystem so they can help grow this, and it's fueled the growth in a massive way. And the costs of the network are extremely low related to or relative to what you might use on another LoRaWAN network server provider. So, a standard sensor sending data once every 5 minutes is going to cost you less than $1 a year on the network, which is remarkable. And you can take any sensor and use it on the Helium network. So pretty much any LoRaWAN sensor built by one of the many manufacturers in the ecosystem will work on the Helium network for use cases. And today we're going to talk about a very special one from KST, which I'm very much in love with. So when I talk about ecosystem, a big part of that is the hardware manufacturers building gateways. So if people are on this call who haven't actually started to deploy coverage yet, I definitely recommend you check out. We'll drop a link in the notes to this, but it's helium.com/mine. Maybe we can get a a link in the chat from Emily or someone out there. So that will point you to all of the options for building coverage on the network, Nebra, Rack, Bobcat, which is easy to link in, Syncrobit, and then there's 3 or 4 other manufacturers that are in the queue to build hardware per the HIP 19 specification that the community puts out there and supports. So plenty of options to continue building the network out. So the Helium network sort of differentiates itself from traditional LoRaWAN by combining LoRaWAN, which is the open protocol on top of LoRa, with the idea of the Helium blockchain, right? The idea that we're incentivizing individuals and companies to build out the network, and that when you get involved in Helium, you might not have a use case for sensors, but you have a use case for wanting to be part of this decentralized network, and that's really the power of what we're building here. And so on the heels, or I guess on the support of that rather, we've managed to bring companies like Nestle and Lime, who are big companies that people have heard of, and then smaller startups like Conserve and Busy Nowie, Careband, and SmartMimic into the ecosystem. So with that, I'm going to hand it over, I think, to you, Bob. Are you going to take control here?
Yep, that sounds great, Mark. Thank you.
All right. Yeah, and why don't you guys kick off with some intros too, so people know who we are.
Yeah, that sounds great. I'm going to also share a screen, Mark, if you're good with that.
Yep, I just killed mine, so it should work.
Cool. Hello, everyone. My name is Bob Crescent. I'm president of KS Technologies. We're an 18-year-old company based out of Colorado Springs, Colorado, which is about 1 hour drive south of Denver. So one of the things that we get really excited about as a company is deploying remote sensor solutions. And it takes kind of a village, so to speak, to get those sensor solutions solving problems on behalf of our customers. So I'm really excited to work with our internal team, and I've got Devin on the phone with me today. He'll be showing you a live demo of how a data packet journeys its way to the cloud through Helium and then eventually to Losant. We also have Heath joining us. He's a customer success engineer for Losant. He's been instrumental in bringing KST up to speed on how their service works, and they are also a really key partner. There's a couple of objectives, and Mark went through some of these already, but a couple of objectives of our webinar today. First, there is a lot of terminology about this ecosystem. So what is Helium? What is LoRa? What is LoRaWAN? What do we mean by a LoRaWAN network server? And so one of our first objectives is to just go over all that terminology, just to make sure it's clear, because that's half the battle sometimes is knowing the words. The second major objective we have is to just take you through that journey of a packet of data from the sensor side, and we're a sensor manufacturer, been doing LoRa for about 3 to 4 years now. I've been doing Helium for a couple of years. We are also miners. And so it's really exciting to see that data eventually journey its way to the cloud. And we love seeing it get into the hands of people and businesses so that they can profit from it. And our third objective is to just kind of get you excited about what the IoT can do. I'm sure you've seen a lot of use cases that are out there. It's really exciting to have strong partners like Helium and Losant in this space so that you can bring an overall solution to your end customers. There's likely at least 3 major groups of people that are in the audience today that I believe will benefit from the webinar. First, you may be a Helium network operator. I mentioned that we are as well, and so we also do mining. And so we're excited to give you some ideas and some use cases on what that could look like. The second group of people we anticipate are IoT engineers that are in the crowd. These are folks who may operate at the hardware level or maybe at the cloud level. I believe this is going to give you a unique perspective on what Helium brings to the table that is really exciting. Like Mark mentioned, one of the largest deployments in the world, which is awesome. And so could you use this network? And so as an IoT engineer, I think you'll benefit from what we're going to discuss. And then third, you may be like me, a business owner, and you're faced with challenges that you hope the IoT can help address. The connectivity piece, which Helium brings to the table, is a major part of how you're going to succeed in deploying an IoT sensor network. The back-end piece that receives that data, and then the front-end piece that processes that data, and this is what Losant brings to the table, is another really important and critical piece of this entire ecosystem. So if you're a business owner trying to solve a particular problem you think the IoT can help, we hope that today's webinar is interesting to you as well. So let's dive right in with some of the terms. You've heard LoRa, and you've heard the term LoRaWAN. And in a minute, we're going to make that distinction. But LoRa, at its fundamental level, is a radio technology. And there are a lot of radio technologies that are typically associated with the IoT. So you may have heard of NFC, near field communications, or BLE, Bluetooth Low Energy. Wi-Fi is something that you probably use every single day. LoRa stacks up with those and can also be compared to cellular technology. But we believe for the IoT, LoRa is in a really unique position to deliver great remote sensing solutions. So let's kind of think about how those different radio technologies stack up in just one key parameter, which is distance or overall RF range. At KST, we love food. And so I'm going to use a food analogy, maybe not the most healthiest food analogy, but I'm going to use a food analogy to kind of tell the story of range and to kind of put it into perspective. NFC is a very short range technology, typically on the order of magnitude of 2 to 10 centimeters. Bluetooth Low Energy is typically a 50-meter type of technology. And that will be our baseline Twinkie for those of you following along with the food analogy at home. That'll be a kind of our baseline Twinkie, 50 meters. If we consider Wi-Fi, it's typically about double that range, or we consider Wi-Fi to be about a 100-meter technology. And that varies depending on the power involved. NFC from a frequency standpoint is about 13 megahertz, BLE is about 2.4 gigahertz, and Wi-Fi is also 2.4 gigahertz. Now, what's interesting is when you move to LoRa, you get quite a bit of a range extension. You may have heard or seen blog posts of LoRaWAN being received like from the other side of the world, which is pretty astounding. What we like to say is that LoRa is typically a 1 to 3 mile or a several kilometer range type of technology. And we've proven that out in the field. And if you compare that to cellular, cellular is kind of the king here when it comes to distance. We consider it about a 10-kilometer type of technology. Now, that's just RF range, and that's a lot of Twinkies. That's just an RF range way of considering these radio technologies. But there's a lot more to consider as well. If you look at cellular, it's a really high bandwidth technology. So you can stream videos to YouTube. You could never do that with LoRa. LoRa has a very limited amount of bandwidth, but that's actually what makes it perfect for sensor technologies. Mark mentioned this idea of waking up and sending data, say, every 5 minutes. That's a perfect example of something that's a great IoT technology. LoRa is also quite a bit less expensive than something like cellular is to operate. So it's less current, less transmission power to get to the cloud, but really ideally suited for something like a sensor network. So that's how LoRa stacks up just from a range perspective. Now, you might have heard me mention this, LoRa and LoRaWAN, and there's actually a really important distinction between the two of them. And the WAN part of LoRaWAN is what really gives Helium a lot of magical powers as far as I'm concerned. So LoRa, you can think of as the physical radio. So you could actually have 2 sensors with LoRa radios in them communicating with each other. It is a bidirectional point-to-point type of system that you could potentially set up. But let's say that I wanted to build a LoRa-based asset tracker, for instance. And let's say that I wanted to drive from Colorado Springs up I-25 here in Colorado through Castle Rock and down into downtown Denver. And I wanted to see GPS coordinates all along the way, maybe pushing every 2 to 5 minutes or something of that order of magnitude. I really need the WAN, the wide area network part of that to make this happen. And this is what's really exciting about the 25,000 plus hotspots that are out there from Helium. I can now bounce from hotspot to hotspot. So in Colorado Springs, as I start driving, I can leave KST where we have a hotspot, and I could go 10 miles away, and I could now connect to a second hotspot and begin pushing data. The WAN part of that really is what allows that to happen. As I drive up through Castle Rock, I'll connect to a hotspot that's up there. And when I get into downtown Denver, where I'm flooded with hotspots, the hotspot with the strongest signal will report that data eventually to the cloud. That's the magic of the WAN part of it. It allows me to build an intensely mobile type of application. And that's really part of the magic of what makes the LoRaWAN portion work. So that's a little bit from a definition perspective. Now let's get into some specifics about a sensor deployment that we've done and how our sensors work with Helium and Losant to solve business problems. Whenever we approach customers and we ask them basic questions about the problems that we're trying to solve, we usually bucket our questions into 3 main categories. And what I love about what Helium has done and what Losant has done is that they allow us to build solutions that allow us to measure data remotely in the field, to interpret that data and to make sense out of it, and then to apply it to a particular business situation. So we're very careful to always ask questions about not only how to make the measurement, but what that measurement's telling us, and then what we can do with the measurement. So let me give you a basic example of what we mean by measuring, interpreting, and applying data. And I would encourage you when you're talking to your own customers to ask them questions along these lines. We tend to get really excited about the measurement aspect of it. So in a moment, Devin's going to show you our KST3320, which is a LoRaWAN-based distance measurement device. And he's going to show you data going to the Helium console and then eventually to Losant Live, which is pretty cool. It's amazing that we can measure with such accuracy. And so imagine that I take a measurement, and this is what our sensor reports, gives you an answer of 384 millimeters. It's good to know that information. However, that's just a measurement. And although that's really great information, that really doesn't help me solve a problem. So we always encourage people to think about, how am I going to interpret that data? So let's imagine that this is a rock salt water softener, and we've done this with our KST3320, and we're measuring rock salt level that's in a particular bin. And let's say that that 384 millimeters means that the sensor is detecting that 384 millimeters away is rock salt. And therefore, we can interpret the data, knowing this container that we're in, that it's 67% full. That data is really valuable now that you've interpreted it. So it's really important to think about this data journey in terms of measuring the data with the sensor, interpreting that data, which has been forwarded on from a Helium LoRaWAN network server. And now we want to make application of that data. So even this is valuable, but not the most valuable. The most valuable thing is when you can apply that data and do something meaningful with it. Does this mean that a rock salt water softener company needs to come out and fill your bin with rock salt? That's really meaningful. You've now applied the data. You've solved a business problem. And so what's really exciting about Helium and Losant is that those key partners allow us to solve overall business problems. It takes that entire network in order to make this really work. And you'll see that network in action here in just a moment. All right, a couple of other terms, then we'll proceed with the demo, and Devin will be taking you through that live. How does a LoRaWAN piece of data get eventually from a sensor to the cloud? At a super high level, all sensor network distributions have three critical components. There's the sensor itself, or the thing that's out on the edge measuring the physical phenomena that we care about. And then there's something, a base station, a concentrator, a hotspot, a cell tower. There's something in the middle that receives that data. And then that data has to eventually get to someplace in the cloud in order for processing, for storage, and then for notifications. And so whether that hotspot is a Wi-Fi hotspot or a BLE gateway or a Helium hotspot, there's always these three critical components. In the demo that we're about to give you next, we have those components and we have them all running. And to go into kind of the next level of detail, we have our sensor, which is our KST3320. It's communicating here locally to a Helium hotspot. That Helium hotspot is going to take that raw packet of data and forward it to the LoRaWAN network server, sometimes called the LNS. The LNS is also part of the overall product that Helium provides. Helium will then decode that encrypted packet of data, and they're going to forward it, in this case, to what is generally called an application server, and specifically part of what KST's layer looks like, which is called covalence. That's our name for an AWS-based server that receives that data and now can make meaningful sense out of that data. We then take that meaningful data and send that over to Losant for visualization, analysis, and notification. Now, as you scale, that middleware layer may or may not be required, but the application server is a critical part of any LoRaWAN network server distribution. So it's possible that you could bypass covalence, which works great, and you could push that data directly to Losant. Maybe you have your own Azure instance and you want to put an application server on your Azure instance, all totally possible. And so with that, I'm going to turn it over to Devin. Devin is going to show you a live view of that data packet journey. He's going to start with our KST3320, which is pictured on the left-hand side of your screen, our distance sensor. It's going to push that data to our local Helium hotspot. That Helium hotspot will forward data to the Helium LoRaWAN network server, the LNS. The LNS will then forward that data to covalence. Covalence will forward that data to Losant, and Losant will ultimately be used to visualize how that data goes. So I appreciate your attention. I'm going to go ahead and turn it over to Devin then. Devin, if you want to go ahead and take over a presentation and take us through some of the details behind what that packet of data looks like. Thanks, Devin. Thanks, everyone.
As Bob mentioned, thanks, Bob. My name is Devin Saavedra. I'm a user interface and user experience engineer here at KST. And so I'm going to start off showing you what the end result will be of a Losant dashboard that we've created. And this is all readily available on Losant itself. If you sign up for it, an account, you can have a sandbox environment, and we have a KST33 series distance sensor application template ready for you to use. So you can see.
Sorry, Devin, to cut you off.
Yeah.
Do you have a physical sensor with you?
I do.
Can you show that? Like, can you hold it up? Because that is so cool.
Yeah.
And it's not. I mean, it's not small, right? It's substantial, that sensor.
Yeah, it's decent size just because of the 2 C-cell batteries we have in here.
Oh,
so
I see. Okay.
Get massive battery life out of this. And
Yep.
it's a ruggedized IPX6 case, so it's environmental friendly outside. Can withstand all kinds of harsh conditions, and you'll still get distance data along with several other sensors we have in here as well.
And what is the actual? I know you're going to talk about this, but the specific sensor type itself that is used to sense distance.
Yeah, so the sensor itself is right here in this window right here. It's a time of flight sensor. So it uses a class 1 laser. So it's non-obtrusive to your eyes, so you can look at it and everything won't blind you or anything. But it just bounces a laser off to something, receives the data back, and gets that distance that way.
Fascinating. How much work did you guys have to do to minimize power consumption of a laser, I guess?
We've done a lot of firmware implementations to get the most battery life out of this device as possible. Because we do it just this distance sensor, but we have GPS on board as well, so you know the exact location of it. So we get at least 18 months battery life in normal conditions. And there are other options as well. We have another distance sensor that's even smaller than this that can fit into a variety of different applications as well.
That's awesome. Okay, sorry, carry on. Just wanted to
That's a great question, Mark. The only thing I would add to that is the beauty of that particular measurement system is that we can write custom algorithms that live right at the edge to make sense out of data. So if you have a highly reflective environment or an environment that absorbs laser energy, so some recyclers do have different materials that can absorb laser energy. That allows us to then change that algorithm at the edge. There's a lot of knobs associated with that particular sensor, which makes it suitable to a variety of applications. So it's a great question. We can tune that, and lowering that power is always one of the substantial challenges related to firmware. So great question.
Looks like, by the way, there's some links to the Losant, to the sensor docs, courtesy of Heath in the chat. So thanks.
Awesome. Cool. So here's the dashboard that we've made with the application template. So you can see kind of just a picture of it. We have fill percentage. So this is the interpreting of the actual measure data we have. We're showing battery percent, and we show distance in inches, millimeters. And we just have a data table over here showing the same stuff, including RISI, which is the received signal strength indicator, and SNR, the signal to noise ratio. Since we have GPS on board, we're showing a map. So this is a live update as of 1:13. Today, we got GPS push. So we do pushes about once per day, and you can tailor that as well. And we do a battery push once per day as well, but that can all be tailored if you need it updated more recently. Down below here, we show some nice charts of distance, historical distance in millimeter and in inches. So you can kind of get a rough estimate of what's happening with your sensor throughout your application. And then we show another chart here for received signal strength and for SNR. These are both really great for when you're deploying your sensors and making sure you're within range of a hotspot, or if you need to get closer, or you deploy another hotspot, you can kind of see exactly where you need to be with your sensors and your hotspots as well. So with the dashboard here, I'm going to jump to the application itself. So if you're on Losant, you can create an application using this template that we've made. So you can scroll down here and you'll see the KST33 series distance sensor. You can click on that. We have a nice README right here. You just click create application and you'll be ready to start sending real data. So what that looks like is you'll get this kind of overview with a README explaining how everything works, but I'm going to give a quick overview of all that right now. So with this particular one, like as Bob mentioned, we use covalence middleware. So we have our Helium endpoint here that you'll put into your Helium console as an integration to route your data from the 3320 to Helium, and then to our covalence middleware, and then back to Losant. So all that's doing really is kind of decoding the data, making it a little easier to use, so you don't have to decode it yourself on the Losant side. So what that looks like is on the Helium console, you can see we got.
Is there an open source decoder for this sensor, Devin?
We have docs on it as well. We can share that with everyone. So we have our last push actually was 2 minutes ago, which is awesome. So you can see the timestamp here. If I scroll up here in the console, the debug console, I'm going to find our payload right here. So that's our payload, and Helium encrypts this as well. So it's base64 encoded. And then you can see the hotspot we have right here. That's local to our office that I hit. So with this, we have our integration, which I'll show right here. So this is our integration, just using a webhook, routing to the Covance middleware, and then from there, go to Losant, to our workflow that we have. So we take that payload we get, just using a webhook here. So this is what a workflow looks like on the Losant side. So with this workflow, you get all of this with the application template. We have another webhook here that's grabbing the data from our Covance middleware. And then we're going to do a check to see if, since we have different payloads, we're going to see if this is our distance payload. And if it is, we're going to go ahead and convert from raw millimeter distance to inches. And then we have the most complex thing within Losant right here is just some custom JavaScript that we wrote that's provided for everyone that just takes the raw distance and does a fill percentage level for it, for what you're measuring. So you can change two values here. The max distance of this sensor is 4 meters, so it's in millimeters, so 4,000. You can change that to the height of whatever you're measuring. And if your sensor is like an air gap, so if you have a gap between the top of what you're measuring and then the rest of everything, you can enter that right here, the height above fill line. And then it'll automatically calculate your fill level in a percent for you. If it's not distance, we go ahead and check to see if it's GPS, and then we grab the location with this node here, which just takes long and turns it into a location. And then we also take the raw meters and convert it into feet. And then last, if it's not either of those, it's going to be our battery, and then we'll just show battery percentage. With this workflow itself too, you can have multiple devices set up within one workflow. So here we're just grabbing our dev UI to look for that, to distinguish between the different devices you have set up. And then we're going to do a quick check to make sure the device exists. So you do have to create the device within your Helium console in order to send the data where you want it to go. And then you have to create the device within Losant so it knows what device it is you're grabbing the data from. Then from here, we got a debug state. This one is, if you don't have a device, it'll show up on the debug console over here as device not found. And here we have our device itself. So since we're decoding everything for you already, these are just all the attributes that you could get out of the payload, along with all the hotspot data as well. So we're showing the carrier, we're showing if you ADR is active, what channel you're on, the gateway ID, which would be the hotspot name, the frequency, the RISI, and the spreading factor. With all of that, you probably saw some of these light up just right now because we got a payload coming. So if I hover over here, you can see exactly what payload we got, which was distance. And then you can see the body right here. I'll just scroll through because this is really fun. You can see, oh, we actually got a GPS payload. So we got GPS, and we can see our altitude in feet, our horizontal and horizontal accuracy, our latitude, longitude, our location, number of satellites we saw, and our vertical accuracy. So what all that looks like, if I come over here, refresh that. So this last one, since we got GPS push, some of the data went away. It'll refresh again once a distance payload comes in. This is the last known packet that comes in. So with this too, you can actually put in another block itself to show latitude, longitude, vertical, and horizontal accuracy and number of satellites if you want that level of accuracy itself. So with that, that's the entire dashboard. Everything's readily available on Losant to get you up and running. I'll probably hand this back over to Bob to talk a little bit more about the sensor itself and what you can do with it.
Can I ask one question about the workflow dashboard?
Definitely, yeah.
So this is more of a general question, but do you find that when working with customers, maybe this question for Heath as well, that this type of programming works when you go from 1 to 5 to 5,000 devices? I mean, does this mean, like, can you use this when really scaling up, or do you have to switch to something that's like purely sort of like code driven versus like a GUI?
No, from what I've played with, and Heath can probably better answer this, but you can scale this to thousands of devices using one workflow. You can batch import all your devices itself and just change the dev UIs and you're good to go. One workflow can handle thousands of devices. Then you may just want to tailor your dashboard itself, since we provide this as just kind of a boilerplate one. You can tailor this to be one big table. You can have multiple different just blocks showing different just millimeter or inches data flowing through. So kind of scale that way better. And then the Losant also provides much more advanced dashboards as well. This is kind of just a good one to get you up and running. But you can fully white label this and make it anything you want. It's really powerful.
Cool, thank you.
No problem.
Heath, did you want to add anything to that?
To pile on top of that a little bit, Devin, in your workflow, one of the things that you can actually include here, were you doing at the very bottom if the device doesn't exist, just a debug? One of the options that you do have in Losant is this workflow could also be processing your data and provisioning devices. So if that device doesn't exist, you can create a brand new device all within one workflow, all in one place. It is common sometimes to break that out and have a device provision itself and then start reporting. But like you said, Mark, you can do all of this in one place and it scales at the same way that a general webhook does.
Evan, I can't believe you didn't know you could provision a device in that debug flow. Just amateur hour. Thank you.
Right, yeah, the only other thing I'll say, Mark, besides thousands of devices at least, which we feel comfortable with, Losant has a whole bunch of other blocks that are built in that workflow. So if you want to add notifications or geofencing, or you want to dump all your raw data to an S3 bucket, or you want to switch to MQTT, I mean, kind of the sky's the limit in terms of what you can add to it. And then if you really need to get crazy with this and brand it your own way and everything, there's something called Losant Experiences as well. And Losant Experiences really allows you to get down and dirty with the data and build really complex dashboards. So that the enterprise level scale is really nicely built into Losant.
Yeah, what I really like about this too for Helium Network users is that what we're focusing on the Helium side is just building a network that works. Right? We're trying to make it as simple as possible and get you data that's typically encrypted before it leaves the platform. And here, every feature that you might want to use to build something on top of that actual sensor data exists. So it's a really nice marriage. I like it a lot.
Yeah, probably the other thing I'll throw out, and this is why we love the partnership with Helium and Losant. So we have our KSE 3320s now available. They've been in volume production for almost 2 years now. And so there's quite a few of them out in the field. And if you have a Helium hotspot, and then if you grab that application template, which requires no coding experience, there's a developer free license that Losant offers. So you could put those three pieces together with no code, build the same thing that Devin just showed you, which is really powerful. We like to use that as a starting point so people can do a proof of concept, play around with the sensor, deploy it out in the field. This is all production grade. Helium, Losant, and KST's device is all production grade. So there's nothing dev kiddish about this. This is high volume and scalable, which is super exciting to me as well.
Nice. Just want to be cognizant of time, by the way. We should probably aim to take questions in maybe 5 or 6 minutes because we are running a little bit late. So just keep that in mind.
Cool. Will do. Devin, you okay if I take over?
Take it over. It's all you.
Let's do it. Let's wrap it up and we'll get to Q&A. So hopefully Devin's kind of giving you a flair, a little bit of what it looks like to put these solutions together. Distance is actually really interesting. There's a number of very complex problems you can solve with distance. It could be as simple as, is someone putting their hands close to an object and you want to take some level of action based on that object, or maybe you want to know how close an object is away. So in this example of a phone, maybe you want to do an autofocus application. So great for that, especially with no dead zone, which is one of the reasons why we really love laser-based measurement systems. Maybe you want to know what the relative proximity is of a piece of equipment with maybe a fixed wall such that something couldn't be damaged. Perhaps you have something that's kind of in the middle of nowhere, but you could stand up a Helium hotspot and you could grab data like what's the liquid level that might be in a tote. I mentioned the rock salt softener earlier, and our little 3320 actually kind of made it into the picture. Could we measure rock salt? This is my basement, incidentally, so I get notifications when my rock salt's running empty, which is handy because I always forget. And then water stinking is not a great way of knowing that your rock salt level is low. This is a lot better. Trust me and my wife on that one. We've even had people ask, hey, can you measure paper products in restrooms? Absolutely. So we have ridiculous accuracy in what we call our IOTP dashboard, but in our own restroom. We can tell you with ridiculous levels of accuracy our toilet paper consumption, more than you ever would want to know. And this also includes paper towels that are in our paper towel dispenser. People counting is a massive application that we do with this, especially thanks to COVID. Knowing utilization of conference rooms, things of that nature. There's our 3320 down there in the picture. We've had people put these on manacle covers to see what's happening under the city. So municipalities love this device. It's very ruggedized, perfect for these kind of use cases. We've had people play with these in parking garages where they can't do pavement-based sensors, but instead they want to look down from above. We've had people put these into industrial situations to know when scraps of metal, for instance, hit a certain height in a bin. We've had people want to know, hey, in my warehouse, which bays are empty, so I know where to send my forklift driver. That's a great application for a distance sensor. We even had someone who said, I want to know how many cardboard boxes are left in a particular bay. Can you tell me when I've got only 10 boxes left so that I can order more? Perfect application for distance sensor. And we've probably enjoyed most volume distributions based on municipal trash collection. So we can tell you whether you've got the open bins or the big flappy bins or even smaller containers like this. We can tell you what the fill level is of those trash containers. So hopefully we've kind of given you a flair for what you can do at distance. Hopefully we've got kind of your juices flowing in terms of what problems can be solved with it. If you're interested in more information, please reach out to us on our website or through our general email address. We'd love to answer any questions that you might have. The KST-3320, like I mentioned, has been in production now for about 2 years. So let us know if you're interested. And then Devin mentioned that we're working on smaller devices. Since this guy is relatively big, it's about 4 inches in diameter and it's about 2 to 2.5 inches thick. But what we have done, and this is an unreleased product yet, but this is our new KST-1520. This takes all the technology that's in there and boils it down to its smallest form factor. So we have a 4 meter sub 10 millimeter resolution class 1 laser based device on one side. And then on the other side, we've got a LoRaWAN radio, a Bluetooth Low Energy radio for local commissioning and for playing with proof of concept stuff, fast streaming of data. We also have an accelerometer so that we know the tilt of your deployment, which can be really interesting, especially in trash applications. And we have a connector on there so that you could do wired bus protocols like USB or UART, I2C, SPI, and you can also bring power to it as well. We're starting to design custom carrier boards for folks and custom enclosures so that you could take this technology. This is looking a lot more attractive for measuring toilet paper than this. And so this is a really nice iteration on what we've done, and we're excited to get that to market within the next quarter or so. And with that, Mark, I'll turn it over to you for a wrap up and for managing Q&A. So thanks.
Yeah, and just leave your slides up here. You don't need to give me the screen back here, Bob. So thank you to Bob and Devin Heath for that fantastic presentation. I think it was excellent. I mean, the product and the whole package is fantastic. Also, I thought that OTP joke was quite funny. I'm not sure why I was the only one who cackled at that. I'm just assuming that everybody was on mute and we couldn't hear them laughing. So
that, Mark. Hopefully we'll
good job on that, Bob. So we've got a few questions. I'm going to take a few from the chat here. I'll start it off with one of my own. So how does one engage with KS Technologies to sort of use this in a product, right? Because you guys are building the sensor and you're using Losant in this case for the dashboard. Let's say someone here on the network wants to go to their town and say, hey, listen, I think I can help you solve a problem with being more efficient about collecting trash across bins. What is their approach to engaging with KST in that respect?
Yeah, that's a great question, Mark. So we found that every deployment has some level of either customization or Q&A or interaction that has to happen. So if you want to talk with us about that, we really would love for you to reach out just on the email address that's on our screen, info@kstechnologies.com. We'd love to just start off with a phone call. Sometimes that leads to like a proof of concept sort of study, Mark. And so we're totally happy supporting quantity of one type sales so that people can get one of these in their hands. Nothing beats playing with it to see what it can and cannot do. And then we go from there. Sometimes that needs to be customized. Sometimes it doesn't. Sometimes folks get really comfortable with Losant and they engage directly with folks like Heath to build their custom solution. We can be involved or not involved, just depending on the technical level of the customer. But starting there and with a phone call is really how we prefer to do it to make sure that we arm you with the right sensor.
Okay, perfect. All right, so get in touch, info@kstechnologies.com. Bob and team will we'll get in touch with you about how to test and use. All right, so a few other things. So Dana DeLuca from the chat asked this a little while ago. So how does the data get into a text message for cellular transmission? So I think this is a question about when you were showing the UIs from the application. So you've got a packet that hits the Helium network, gets passed through to Losant. Where in that flow does it end up as an SMS, and how does that get delivered?
Yeah, that's a great question. So it actually happens in that Losant workflow. So if you remember that workflow that Devin had up, there's actually one of the elements of the workflow that can be dragged in, which represents SMS. And so what you can do then is put in a Losant template message in there, and then you can like insert phone numbers or whatever. We actually had a smart city that after they saw the Losant dashboard, they loved it, by the way. It was a smart city and they just stuck with the basic default Losant dashboard we created, which is awesome. But they came back to us after about a month and they said, hey, we really want to send a text message to our driver so that our driver has a Google map and all they have to do is tap on that with an SMS message and just get routed to it. And so we did that all in Losant, zero code. Devin can correct me if I'm wrong, but I believe that was zero code. And then we associated his phone number in the Losant backend. And so then that would send the SMS. And it's pretty cool because you get the SMS and it has a Google Map link on it. You hit tap, you hit route, and it just takes you to wherever that trash can is located. So
that's super
in
cool.
That example, the SMS is taken care of directly on the Losant backend.
Nice.
Heath, did you want to add anything to that?
Yeah, so I was going to say the base SMS node, so those little pieces that Devin was showing up, we call those nodes. The base SMS node is a little bit rate limited. It's more of a proof of concept. You're sending a single text message every 10 minutes. But we do have a Twilio node. So you can have your own Twilio account and run all of your SMS data and stuff through a Twilio account that you've got your money on and can kind of control your own rates that way.
Super cool. Yeah, I was going to ask if you guys used Twilio in the backend for that, implemented your own, but good to hear that you used that versus writing your own SMS.
Yeah, and same with email and same with Slack. So we do have inbound webhooks. We also have outbound HTTP calls. So anything that you can trigger with an HTTP request, we can do it, as well as with emails and SendGrid nodes. So we do implement SendGrid on our side. So same with SendGrid as with Twilio. So if you have a SendGrid account, you can send as many emails as I think you could probably afford.
Nice. Okay, a few more questions. So I'm going to butcher this name, but Munir is asking, why is the sensor so big? And you addressed that a second ago here, Bob, mentioning that you sort of cut it down in size. But battery, GPS, electronics, those things add up pretty quickly. But it sounds like you're sort of reacting to that with the smaller design.
Yeah, what's interesting is everyone even has different battery requirements, Mark, which is what pushed us into the new KSE 1520. So we've got friends in Canada and we've got friends down in Mexico, and the temperatures can get really extreme. And so we decided instead of doing a whole family that had different battery products, it just made sense to make that smallest possible element and then deploy with whatever battery technology makes the most sense.
I wonder if you could integrate one of those directly into a Helium hotspot. That would be super cool. Just sort of bolt on a sensor.
I see no reason to do that, Mark. And there's some interesting applications for that too, by the way.
Yeah. Okay. Note to people on the call. Maybe we'll do that. All right. I think you mentioned the rating before, but Otar is asking specifically if it's IP67 rated. But what is the actual rating of the 3320?
Yeah, it's a great question. It's IPX6. So the X is the dust proofness of it, which we did not test and certify. And then the 6 is the water aspects of it. So it can get wet. It can even be submerged for some period of time. I believe the spec is 1 meter for, don't write me, but I think it's 5 minutes. It's pretty meager. So, but it can be dunked underwater. In future solutions, we're looking at ultrasonic welding for IP67. And we're finding that a lot of our IoT customers love the idea of a 67 device. They want to be able to submerge it for up to 30 minutes and sustain no damage. But we're IPX6 currently on the KSE 3320.
Nice. Okay. What is the cost of the sensor itself?
Yeah. So if you come to us with a unit 1 cost, and that includes the Losant application template, and if you bring your own Helium connectivity to the table, don't quote me on this, but we'll send it out later. I believe it's $250 US per unit. Okay. And then that scales accordingly with volume. So once you exceed 1,000 pieces, that goes down quite a bit, like in half, if not cheaper kind of thing. So please reach out to us if you want to know more information about volume sales, but I believe it's $250 US quantities of 1.
Got it. Okay. So another question from Dana. So is there some documentation, some guideline documentation for building your own sensors? This is more Helium specific. So Dana, you're going to want to go to docs.helium.com and look for our device guides. You should also check out the Discord channel. There's a handful of specific channels inside of Discord. So the sensor dev and the console channel, probably your best bets there. We can drop some links in the chat. Let's see. Marcus is excited about Twilio. Is your application support do you support multi-tenant architecture and single sign-on? So I think that's probably more of a question for Heath and Losant.
Yeah, absolutely. And the answer to both of those questions is a resounding yes. Our multi-tenant functionality is our bread and butter. It's one of the things that we pride ourselves in, and as well as SSO. So you can implement SSO for the people accessing. I think Devin, you had mentioned our experiences, so you can implement SSO. We do have a great walkthrough on how to walk through that implementation yourself. And then for the multi-tenant aspect, you can go as small as just one tenant, and then like the name says, multi-tenancy into a very wide and complex network of multi-tenancy.
Okay, cool. Okay, two more questions and we're gonna wrap it up. I'm gonna attempt to take one of them and I'm gonna kick the other one back to Bob. So I'm gonna say this wrong. Vabav is asking, what is the battery life and frequency of data push from the sensors? So let's see if I heard you correctly, Bob. So the 3320 can operate for up to 18 months. Is that what you said?
Yep.
And it's configurable in terms of how often it sends data.
Yeah, that's a great question. So the default firmware supports 18 months, and that's one uplink every 15 minutes, 24 hours a day, 7 days a week. We typically do GPS once per day, but that's configurable. And we typically do battery once per day, and this is also configurable. The other thing I'll mention there is we also support full uplinking and downlinking. So I mentioned that LoRaWAN is a bi-directional technology. We support downlinking. So if you want to do something more frequently than 15 minutes or less frequently, or you want to take advantage of our business hours API and say, I don't care about distance from midnight to 6 in the morning. I want to save that time on radio. That all scales with respect to battery life. So that's all configurable through downlinking. And I believe we have a firmware guide on our website that gives you the uplinking and downlinking payloads so that you know how that gets configured.
And it's a class A device, yes?
That's correct, class A.
Okay. Okay. All right. And so one more for you. Actually, well, two more, I think, because we can just cut it off at two more. We'll take this one and then the question from Constantine after. So why did you go with Helium for this instead of something like NB-IoT?
Yeah, so NB-IoT is more on the cellular technology, and here in the United States, NB-IoT, I hope the carriers aren't logged in.
I hope they're logged in. Tell them what they need to hear.
Somewhat non-existent, Mark. Maybe that was a little blunt, but we found it somewhat non-existent. Cat-M1 is more readily available in the United States, but there is a significant power difference. I mean, a transmit pulse is probably 3x the current on something like Cat-M1 as opposed to a LoRaWAN. So it's purely a power play at this point. Plus the radio technology from Semtech is a lot less expensive than what we found for pre-certified modem radio. So it's an expense play. Our packets are like 12 bytes a bit, 12 bytes an uplink. I mean, it's really efficient, and there's a lot of overhead associated with cellular, even if it was NB-IoT. So we're curious to see how those emerge, but for now, Helium and 25,000 hotspots globally, we love that, and we love being on that network.
Awesome. I mean, we love that too. That's why we're here. Okay, last question. Can the sensor be equipped with a rechargeable battery indoor connected to a panel, solar panel?
Absolutely. As a matter of fact, with the KST20, one of our motivations was we have a customer with a 1-watt solar panel, and they want to put something in the middle of nowhere, but they have a substation that has power, and they want to put a Helium hotspot in that substation, and then they can have a 1 to 3 mile radius of reporting devices that are solar based. Absolutely doable. So we have a baseboard design. This is a little spontaneous. We have a baseboard design that holds the KST1520. That white square is the module. And this particular customer requested a particular battery type. So they wanted certain batteries. They wanted USB streaming data capability when plugged in. And so we designed a custom baseboard for them that the KST1520 plugs into. We have another customer who wants a 1-watt solar panel recharge capability. And we see no problems with that, especially since we support VBus 5-volt power from USB devices. So totally doable, Mark.
Okay. All right. Well, Constantine, totally doable. Get in there. All right. Well, we'll cut it there. This has been awesome. And thank you to the hundreds of people who stuck around for the 60 minutes. I think it has been completely compelling. Thank you to Heath. Thank you to Bob. Thank you to Devin. The info is here, info@kstechnologies.com, and Losant is, I think, just losant.com, right, Heath?
Yep, losant.com and hello@losant.com.
There we go. Okay. All right. Well, thanks everybody for joining. We'll see you in Discord. And most importantly, thanks for being part of the People's Network. We love doing this, and we'll catch you on the next uplink. Thanks, everybody.
Excellent. Thanks, everyone.
Thank
Take care.
you.
Bye.